Hello, this is Riley Benavides. I'm in Susan's lab section 2 for CECS 225, and this is my 8-bit parity lab. As you can see, I have coded it in Vivado. This is my design source right here, and my test bench is right here. And unfortunately, and I really do not know why, but in order to get credit, I am turning in this assignment anyways. My timing diagram did not come out as well as I thought it would have. But yeah, I will go over that in my document. I'll explain to the best of my ability because I do know what is going on, but I could not figure out, I guess, well, you, Professor, you can be the judge of, of my code. But anyways, this is an 8-bit input and 1 output schematic. So right here, you can see that these 2 inputs come to this XOR gate to have an output right there. These 2 inputs come to this XOR gate to have an output right there, and these 2 outputs turn into inputs for this XOR gate, which will have another output. And same thing for these 2 inputs. They both go into their own XOR gates, and then after you have an output from each one, you will have another XOR gate, and then these outputs from these XOR gates go into this final one, and you'll have a final output. As you can see, there's 1, 2, 3, 4, 5, 6, 7 different functions, I guess you can call them, to get to your output. So yeah, this is my schematics right here. As you can see, 8 inputs, and yeah. And so for my design source, this is my coding. I assigned these variables right here, A, B, and P, and I wired the nots, the ands, and the ors, the not A, not B, the NAND AB, the NAND AB for the other ones. Yeah, and if you come down to my Morbit comp, this is where the meat of the programming is. Here are my 8 inputs with my 1 final output called O parity. And the first 4 operations are listed right here. I assigned them operation 1, operation 2, operation 3, and operation 4. And that signifies these 4 operations. And I have, after that, we have 2 more operations. So I called these ones operation 1 underscore operation 2 because it is an operation between these 2 right here, the outputs of these 2 right here. And same goes for these, operation 3 underscore operation 4, because it is the operations for the outputs from these ones. And if you look back up at the schematic, it is these operations right here. And yeah, right here I am defining all of my operations and what inputs go into each one. So for operation 1, we have input D0 and D1, operation 2, D2 and D3, and so on. And operation 1 underscore operation 2 has inputs operation 1 and operation 2. Operation 3 underscore operation 4 has inputs operation 3 and operation 4. And the final operation, which I found in your pseudos, called O parity, is the operation between operation 1 underscore operation 2 and operation 3 underscore operation 4. And yeah, I do not know why I have it copy and pasted twice. I will delete one of these real quick. But after that, I have my test bench code, and I thought I did pretty good on it, but it did not, obviously right here, it did not give me what I needed to see in my timing diagram. But I will go through my test bench anyways. So we have assigned A 8 different variations, and we have wired the final operation is P. To make things shorter, we assigned an integer I to use in a for loop, and right here we have I equals 0 to I is less than 256 for binary, and we increment it by 1. And for each operation, we set A equal to I. And yeah, so that is my lab. Again, I really don't know why my test bench did not output what I thought it would. I followed the pseudocode and I tweaked with it a lot. But yeah, I will ask you in our next lab what I could have done better to fix my coding. But that is the 8-bit parity. Thank you.